Okay, so yesterday we did it till this, and I asked you if you have any questions, please let me know. Okay. Now we're gonna go forward with this, and we're gonna work on. It's called basically forces on an inclined plane. So an inclined plane basically looks like this, and of course has to have some base like this. There would be some angle theta to the inclination, and then there could be an object. So what you're gonna do basically is that first of all you're gonna see where the weight is acting. So the weight basically acts downwards. So let's call that weight. And now weight can be resolved into its two components. One will always be down the slope and one perpendicular to the slope. So this is weights perpendicular component, and this is weights down the slope component. Is it clear, everybody? Now what you guys need to remember is that this angle, which is the inclination angle, is the same as the angle between the perpendicular component and the weight. Is it clear, everybody? Any questions? Now this will stay fixed, so you guys need to remember this, okay? Now, there could be other forces acting at that time, but we're gonna look at them one by one through examples. So first example that we need to look at is that there is a slope. It is at 30 degrees. There is an object which has a says object of weight 20 Newton rests on an inclined plane. The friction force of 4 Newton acts upwards. Okay, like that. Now, first of all, they want to find, in the first part, they want us to find the resultant force. Then they want us to find the acceleration of brick, and finally they want us to find the reaction force on the brick by the slope. This is what we're looking at. Okay, now what I'm saying is, the first thing you should always do, the first step is to make the weight vertically downwards. This is the weight. and the weight was basically 20 newtons, right? I'm going to write W. Then one component of the weight always down the slope and one component perpendicular to the slope. And the angle 30, like I said, it will always be, what is happening really, na? Okay, so one component down the slope, one like this, and the angle here would be 30 degrees. This would mean that this component will be 20 cos of 30, because this is the basically next to the angle, and this will be 20 sine of 30. And in the question they've already said that there is a friction force that is acting upwards of 4 newtons. Do you guys understand this?
Yes, sir.
If the friction is acting upwards, I have no idea what has gotten into it. Okay. So that would mean that the reaction force, which is basically from the slope itself, would be upwards. Let's make it R. So first of all, we want to find the resultant force. So one thing you should always remember is that there is no other force like perpendicular slope except for R and 20 cos theta. So we are just looking at the forces which are parallel to the slope. So resultant force is equal to MA, but we just need resultant force, so we don't need this. Okay, never mind. So what we're going to do is we're going to do 20 sine of 30 minus 4, because basically it is like you want to know what exactly is happening on the slope. So this would mean that the answer to this should be about 6.0 newtons. Is it clear, everybody?
Yes, sir.
Can you repeat it?
Yes. So once you break W into components, right? So the blue ones. So we're only looking at basically this line. Do you understand? Like the slope.
Yes.
So on this one, this is down minus whatever is up. So when I did it, I got resultant force to be 6. Is it clear?
Yes.
Now we would like to find the acceleration. Because resultant force is given by F equals to ma. So what I can do is, I can simply write the mass, because we have the weight. So weight divided by 9.81 would be the mass, multiplied by the acceleration, and the resultant force we have already found to be 6. So the acceleration would be 9.81 times 6 divided by 20, which would be about 2.9 meters per second square. Understood? Any questions?
Can you repeat this one?
So we already got the resultant force before in the previous part, right? You know that F is equal to ma, right? We don't have mass, but we have weight. Because weight is equal to mg, to find the mass, I would divide weight with 9.81. Understood? So put 6 here, which is the resultant force, 20 divided by 9.81 times A. Now we can find A, which will be 2.9 meters per second square. Do you understand?
Yes, thank you.
Now, then it says the reaction force on the brick by the slope. So reaction force is this force, and reaction comes from the forces which are basically pushing the brick down, and the only force that's pushing against the slope is this one, which means that the reaction force will be equal to, if you look at it, 20 cos of 30, because that's the only perpendicular flow force, and that is balanced by the reaction. So the reaction should come out so the reaction would be 17.3 newtons. Any questions? Please look at it, let me know. Okay. Now this is a sort of a question which is connected to, say, it could be connected to kinematics as well. So let's look at that too. So let's do one more question. So it says an object of mass 10 kg rests on an inclined plane of 10 degrees from horizontal. Now it says the length of this plane is 5 meters. So it says ignoring any effects of friction, calculate the time taken for the object to reach down the slope. Okay. So they have given you a sort of a drawing where they have now made this as 10 degrees. There is an object right here. This distance they have shown is 5 meters, and that's it, right? And they want you to find basically the time it takes to roll down. Now, what you're gonna do first? Who's gonna tell me what should we do first? Yes, bachcho. Anything.
Draw the forces acting on the ball. The weight.
Which is the first force we should draw?
The weight.
The weight. So the weight will always act downwards. So let's write weight. So then one component down the slope, one component perpendicular to the slope. And this angle is going to be 10 degrees. Right? As I told you that this is the same as the inclination. This will be W cos theta. This will be W sin theta. Since there is no friction, so we're going to ignore that. And W cos theta is being balanced out by R, so we don't really need W cos theta, we just need W sin theta, right? Now check this out. So if I write that the resultant force F is equal to W sin theta, because the other force is balanced by the reaction, would it be wrong? What do you guys say? So because this and this is like R is equal to W cos theta, it's balanced. The only force that is like left is W sine theta. So I'm going to write W as mass times acceleration due to gravity sine theta. Mass is 10 kg, this is 9.81, and sine of 10 degrees. This should give you a net force of 17.0 newtons. Is it clear, everybody?
Yes, sir.
Yes, sir.
Now the next thing we want is, we want the acceleration, because this resultant force will cause some acceleration. So for acceleration, the mass is 10, acceleration is A. In fact, I'll write it here. So force was 17.0, mass was 10, acceleration was A. So acceleration will be 17.0 divided by 10. That would be 1.70 meters per second square, right? Now because we have acceleration which is constant, so we're going to use SUVAT to find the time. The displacement was 5 meter, initial velocity was 0, the final velocity is not known, acceleration is 1.70, and the time is required. Which equation would be the best suited to write here? What do you say?
S is equal to ut plus half at square.
Yes, Javiria, that's correct. S equals to ut plus half at square, because it does not have final velocity in it. So displacement is 5, this will be 0, this will be half, this will be 1.7, and this will be t squared. So then this will be 5 into 2 divided by 1.7 root, that is going to give us t. And if you find it out, it is going to be equal to 2.4 seconds. Is it clear, everybody? Look at this and let me know if something is still bothering you. Okay. Everything is clear? Should I go on then?
Yes, sir.
Okay. Now, so this is basically the type of questions that you should expect, and they're pretty easy once you know that you need to make two components of the weight, and if there are other forces, you can just resolve them in one line, which makes it super easy. But then there are other cases of Newton's second law, and then now we're going to look at them one by one. So first of all, we have case 1. Case 1 is when two bodies are connected with an inextensible string. Now, suppose there is one body like this, there is another body like this. This has 4 kg mass, this has 2 kg mass, and they're connected to a string. So let's call this M1, let's call this M2. Okay. Now they are being pulled by a force of say 100 newtons. Okay. Which will definitely cause M2 to have a tension T2 that is pulling M1, and M1 will have tension T1 to pulling M2, right? Is it clear, everybody?
Yes, sir.
Now in a case where you see that they have a force like this and they're connected, so you should remember the step 1 would always be to find the acceleration of whole system. Now, how do we do this? Now, we know that the formula that connects force and acceleration is F equals to ma. When two masses are connected, basically what you're going to do is you're going to add those masses together and then add all the forces and then A. So the force right now is 100 and the mass 1 was 2, the mass 2 was 4 times A. So the acceleration will be 100 divided by 6, which makes it 16.7 meters per second square. Is it clear?
Yes.
Basically, it means that the whole system has just one acceleration. So I'm just going to write a note here so you guys don't remember. This acceleration is same for both bodies because you involve them. That's fine. Now step 2 is that find the force on first body by excluding others. Okay, so what you're going to do is you're going to break this from the center, and you can take any body, it doesn't really matter. So you will see that the first body m1, when you isolate it, it basically looks like this. This is m1, this is 2 kg, and the only force that is there is T1. There's no other force on it. Is it clear?
Yes.
But because the acceleration for the both bodies were same, so acceleration is 16.7. What I'm going to do is I'm going to use F equals to ma again. The only force here is T1, so I'm going to write T1. The mass was 2 and multiply by the acceleration. So this is going to give me 33 newtons. Is it clear?
Yes.
Yes.
Now I can also find with respect to the other body. So, or if you take the other body, the 4 one, you realize that basically M2, which was 4 kg, has one force on this side which was 100 newtons and one force this side, this was T2. You can check out the diagram, you see. Is it clear?
Yes.
Now what you're going to do is that resolve the forces again. F equals to ma. So now there are two forces and they're opposite to each other. So I'm going to write 100 minus T2 equals to mass was 4 kg and the acceleration for both bodies is the same. So it has to be the same acceleration because they're moving together. Now if I do this, I'll show you from the calculator actually. For some reason I closed it. So it is going to be 100 minus 4 times 16.7. So this comes out to be T2 as 33 newtons as well. Now, can anybody tell me why T1 and T2 are same? Why did they come out the same although they're two different masses? Any idea? Now this is because, I just want to tell you, T1 and T2 will always be the same because of Newton's third law, which basically states that if suppose M1 pulls M2 with a certain amount of force, which is 33 newtons, so an equal and opposite force will be applied by M2 on M1. Do you guys understand this? So
Yes.
they have to be the same, can't be different. Okay. Now let's do a difficult question. I'm just going to do case 2 when there are multiple masses connected, moving together. So let's look at it like a train. So, like a train would have the engine, and then okay, let me move it a bit on that side. Train got a bit longer. So suppose they say that this has 14 m mass, this has 5 m mass, this has 4 m, this has 2 m. Well, let's just remove this. We can do it with 3. Let's make the wheels as well. Wouldn't move if there are no wheels? Okay. Now they have given you that the engine force is 8,000 newtons. The friction on the engine is 900 newtons. The friction on this is 800 newtons. The friction on this is 700 newtons. And the friction on this is 600 newtons. Okay. Now, as we know now that basically each cable, like this is call it cable 1, okay, 3, cable 2, cable 1. So each one will have its own tension. So let's call this T3. This will have T2, because we just learned that according to Newton's third law, the tension remains the same between in the string. Is it clear? So this is the question, right? Now they say M here is equal to 500 kgs. Now, what is the first step that I should take? Any idea? Anyone?
Find the acceleration of the whole system.
Find the acceleration. Okay, so to find the acceleration, I would use F equals to ma. Now, on the right hand side, we have 8,000. So I'm going to write 8,000 minus 900 minus 800 minus 700 minus 600. Okay. The total mass here was 14 plus 5 plus 4 plus 2 and m. So basically it is, each one has 500 kg, so I'm just multiplying, because if I just took m common, right? So it's just like say 25 m. Is it clear, everybody? Multiply by the acceleration. Now if you find it out, it is going to be 0.40 meters per second square. Understood?
Yes.
Once you have the acceleration, now you can actually one by one do it. So for cable 1, we're going to cut it right here. If I cut it, I'm going to redraw this. I can see it is 2m. There is T1 on this side and 600 newtons on this side, and then acceleration is the same as 0.40 meters per second square. That's for the whole system. So I'm going to use F equals to ma. I'm going to put T1 minus 600 equals to mass is 2 times 500 and the acceleration is 0.40. So if you do this, you should expect an answer of 1000 newtons. Is it clear, everybody?
Yes, sir.
Then what I'm going to do is I'm going to look at the cable 2. So the cable 2, we want to cut it right from here and then redraw the whole drawing. So for this one, we got 4m. There is one force here which is 700 newtons, and there is also T1 here, as you can see from the diagram, and also T2, and the acceleration is the same. So now applying F equals to ma. So T2 minus T1 minus 700 equals to 4 times 500 times 0.40. We already found T1 in the previous part, so you can write 1000 minus 700. This will be, I think, 2000 times 0.40. So this should come out as 2500 newtons. Is it clear, everybody?
Yes, sir.
Okay. Now, so the next thing we're going to do is to find what is happening in cable 3. So I'm going to cut it right from here and check it. It's 5m. So let's draw this again. This was 5m. There was T3 here. There was T2 on this side, and it also had 800 Newton of friction force. And of course the acceleration remains the same, z 0.40. Now, so doing F equals to ma, so T3 minus T2 minus 800 equals to 5 times 500 times 0.40. T2 we already found in the previous part, that is 2500 minus 800. 5 times 500 is 2500 and times 0.40. So T3 should come out as 4300 newtons. Is it clear, everybody?
Yes, sir.
Now, to check it whether my answers are correct, what I want you people to do is to just look at this section only and see if the T3 I found is the same as the T3 that you're gonna find acting on the engine. Can you please do this?
So can you repeat what you want us to do?
I want you to use the engine diagram, only the engine, and prove that the T3 that I found from the third, car to be the same as T3 acting on the engine. That's what I want you to prove. Okay, when the meeting ends, please rejoin, okay? Okay, so now please complete this. Let's see who can prove this first. Okay, is it done? You guys? Is Rameen here today? Okay, she's not. You guys can hear me, right?
Yes, sir.
Okay. I didn't think that would take so much time.
Sir, I got 4,800, 4,300 again.
Okay, that's good. It means this value is correct. So, who could not get the answer? Please tell me.
Sir, I got negative 4,300.
Okay, that's not correct then. It means you have messed up with the signs. So there is like 900 force friction here, and there is T3. Is that correct? This is all right, and the acceleration is 0.40. So when you do this,
Yes, sir.
you're gonna write F equals to ma 8000 minus, because I'm taking all the forces to the right positive, that's why I'm taking all the forces to the left negative, right? Minus T3 minus 900 equals to 14 times 500 times 0.40. So if you try to calculate this, this is going to be 8000 minus 900, 17, and then you're going to subtract 14 into 500 times 0.40. So this is going to be T3 equal to 4300 newtons shown. Is it clear, everybody? Aisha, why are you late? So I hope now you guys understand the concept behind it. And will you be able to do the questions like these? Both the slope and this one?
Yes, sir.
Okay. So I'm gonna see you in the next class then.